Today I will be going over Target 8 and Target 9 notes on graphing quadratics in vertex form for Target 8 and Target 9 standard form. Vertex form for quadratics is called vertex form because it tells you the vertex. So as you see in the general equation up here, that is how our vertex form will always look. We'll have that parentheses squared. Inside of it, you are going to see the letters H and K. H and K represent the vertex. The one thing we have to be careful about is you're going to see the negative sign that happens in front of H. So whenever you pull H out of the equation, you need to make sure you take the opposite of that value. H is also telling us the horizontal shift. So if we are going left or right from that parent function. K, the value at the end, is telling you the y value of the vertex, which tells us the vertical shift, or if our graph is going up or down from that parent function. The a value in the front is telling us the vertical stretch or shrink of the graph. If the graph is vertically stretched, it's going to be taller and skinnier. If the graph is vertically shrunk, it's going to be fatter and wider. If that a value is negative, there's going to be a reflection. So if our a value is positive, my graph is opening up. If my a value is negative, my graph is opening down. In order to solve for our x-intercepts, in step number 3 we see here, we are going to be using the square root method to solve for our x-intercepts. And then we'll finish graphing this up using our x-intercepts, our y-intercepts, and using that 1, 3, 5, 7 pattern you learned back in Algebra 1. So there's a lot of information up there. Let's use it in a couple problems. On A, the first thing it's going to ask us is for our vertex. Remember our vertex, we're going to use our H and K value. We always need to take the opposite of that H. So instead of positive 2, my vertex is going to be at negative 2. You're always going to keep the K exactly how it is. So negative 2, negative 9. For my transformations, my H value, or my negative 2 value here, tells me that my graph is moving left 2. The negative 9, or my K value, tells me that my graph is moving down 9. My a value in the front of my equation is just a positive 1. Since it's positive, it's not reflected, so I don't need to write anything. And since it's just 1, it's not being vertically stretched or shrank. So the only two transformations I have here are left 2 and down 9. To find my x-intercepts, or step 3, it said to set our equation equal to 0. So I'm going to replace my y value with 0 because I know all x-intercepts have a y value of 0. So 0 equals x plus 2 squared minus 9. We're going to use the square root method here because it is the fastest method to solve this. So square root method, I need to isolate everything that's squared. So I'll add 9 to both sides. So 9 equals x plus 2 squared. My entire right-hand side is squared, so in order to get rid of that, I take the square root of both sides. Don't forget to add the plus or minus. The square root of 9 is 3, so I have plus or minus 3 equals x plus 2. Subtract 2 from both sides. Be careful here, that's positive 3 minus 2, which is 1, and negative 3 minus 2, which is negative 5. So my two x-intercepts are at 1, 0, and negative 5, 0. To find your y-intercept, we always plug in 0 for x. So I'll plug 0 in for x, plug 0. So y equals 0 plus 2 squared minus 9. 0 plus 2 is 2, so I have 2 squared minus 9. 2 squared is 4, and 4 minus 9 is a negative 5. So my y-intercept is negative 5. So I can use all this information to help me graph. I'm going to start my graph with my vertex at negative 2, negative 9. I have my y-intercept that I solve for at 0, negative 5. And I have my two x-intercepts. One of them is at a positive 1, 0, and the other one's at a negative 5, 0. You need to try to have 5 points on your graph every time. When I look at this, I know my quadratics are symmetrical, so I can reflect my purple point here or my y-intercept. It's 2 to the right of the middle of my graph, so I can do it 2 to the left. You can also use your 1, 3, 5, 7 pattern to help you finish the graph. Back from Algebra 1, remember we always multiply this by our a value. Since here my a value is 1, I don't need to multiply it. So remember that told me from the vertex I would go up 1, right 1, up 1, left 1. From that point I would go up 3, right 1, up 3, left 1, and then from those points we can go up 5, right 1, and up 5, left 1, which would take us to our x-intercepts. Make sure you connect your points. It is a quadratic graph, so it needs to come to a curve and not a point at the bottom. Okay, let's look at B. So B, again, the first thing it asks us for is my vertex. From that negative 4, I know I have an x value of positive 4 on my vertex. From my value of plus 8 at the end, I know I have a value of positive 8 for the y. Those two will cause two different transformations for me. The 4 is going to move my graph to the right 4. The 8 from my vertex is going to move my graph up 8. This time we do have an a value up front of negative 2. So the negative is going to reflect my graph. And the 2, since it is bigger than 1, is going to stretch my graph. So I'm going to have a stretch and a reflect. And so you might want to make a note to yourself when you look at that value. If your absolute value of your a, so ignoring that negative sign, is greater than 1, we're going to have a stretch. If the absolute value of your a value is less than 1, we're going to have a shrink. Okay, so that's going to happen if your a value is something like 1/2, 1/3, 2/3, something smaller than 1. To find my x-intercepts, I'm going to do the same thing as I did in A. I'm going to plug in 0 for y. So 0, negative 2, x minus 4 squared plus 8. To solve this, I'm going to subtract 8 from both sides. So negative 8 equals negative 2 times x minus 4 squared. We'll divide by that negative 2, so I get a positive 4 equals x minus 4 squared. Take the square root of both sides. The square root of 4 is 2, so I have plus or minus 2 equals x minus 4. To get x by itself, I'll add 4 to both sides. So I have a positive 2 plus 4, so I have 6 as one of my x-intercepts, and I have a negative 2 plus 4, so I have 2 as my other. To find your y-intercept, we're going to do the same thing again. We're going to plug in 0 for x, so you always plug in 0 for the other variable. So I'm going to have negative 2 times 0 minus 4 squared plus 8. So we have negative 2. 0 minus 4 is negative 4, so negative 4 squared plus 8. Negative 4 squared is a positive 16, so I have negative 2 times 16 plus 8. Negative 2 times 16 is a negative 32 plus 8. So I know my y-intercept is going to be down at a negative 24. So that won't end up getting graphed, but we still need to know that point. So for my graph, I have 3 points right now. I have my vertex at 4, 8. And I have my two x-intercepts at 2, 0 and 6, 0. To get our other points, we can use our 1, 3, 5, 7 pattern. But this time we have to remember our a equal to negative 2. So we need to multiply each of those values by negative 2. So starting from my vertex, that tells me I need to go 2 down and 1 to the right, 2 down, 1 to the left. That's going to give me my first point. Then I would go 6 down, 1 to the right. I'd go 6 down, 1 to the left, and that's going to give me my next two, which end up on this one being those x-intercepts. We have our 5 points, so we're going to connect, make sure your graph comes to a curve and not to a point, and we have our second quadratic graph. You notice that this one opens up going down. That's because that negative a value reflected it. Okay, target 9, we're going to continue graphing, but we're going to be in a different form this time. This one's called standard form. You know something's in standard form because it's all multiplied out. You'll never have any parentheses left in your standard form. In order to find that axis of symmetry, or the x-coordinate of the vertex, so the axis of symmetry was that line I drew through my quadratic graph, we're going to use the equation x equals negative b over 2a. That should seem similar from Algebra 1. You will have to memorize that, or make sure you get all your homework done and you can put that on your yellow sheet for the test. After we find our vertex x value, number 2 says we're going to plug that in to find our y coordinates. They're not going to automatically give you the y value of the vertex in your equation, but we'll have to plug that x value in to find it. In order to find our x-intercepts, we're going to continue to set the equation equal to 0, but now we're either going to have to factor or use the quadratic formula to solve for the x-intercepts. And then we'll go ahead and graph it. So my axis of symmetry, starting on A, we need to use our x equals negative b over 2a. Remember, our a value is the number in front of x squared, your b value is in front of x, and your c value is your constant. So for negative b over 2a, I'm going to have negative 8 over 2 times 1, which is 2. So negative 8 divided by 2 is negative 4. And we'll always write our axis of symmetry as an equation. It will always be x equals. So to find my vertex, I know the x value of my vertex is negative 4, but I need to solve for that y value. So I'm going to plug negative 4 into my equation. So I have y equals negative 4 squared plus 8 times negative 4 plus 12. Negative 4 squared is 16. 8 times negative 4 is negative 32 plus 12. Well, 16 minus 32 is negative 16. Negative 16 plus 12 is negative 4. So my vertex here is negative 4, negative 4. In order to find my x-intercepts, we always plug 0 in for y. So 0 equals x squared plus 8x plus 12. You can try to factor this, or you can try to use the quadratic formula. The quadratic formula will always work, but factoring is faster. I will use factoring for this one, especially since I see my a value is 1. So I'm looking for two numbers then that are going to multiply to 12 and add to 8. I know since I have x squared, I'll have x in the front of each of my parentheses. Multiplying to a positive 12 and adding to a positive 8 is going to be a positive 6 and a positive 2. Setting those equal to 0, I get x equals negative 6. So I have one x-intercept at negative 6, 0. Notice we'll always write our intercepts as points, as they are points on our graph. My other x-intercept is at negative 2, 0. To solve for my y-intercept, just as we did in our vertex form, we're going to plug in 0 for x. So we have y equals 0 squared plus 8 times 0 plus 12. Well, 0 squared is 0, 8 times 0 is 0, so my y-intercept is at 0, 12. The constant in standard form, or your c value in standard form, is always going to tell you what your y-intercept is. So my vertex on this one is at negative 4, negative 4. My x-intercepts are at negative 6, 0 and negative 2, 0. I want to get 2 more points on there, so I'm going to use my 1, 3, 5, 7 pattern. My a value on this one, again, was a positive 1, so I don't need to multiply that by anything. So from my vertex, I'm going to go up 1, right 1, and up 1, left 1. Now I have my 5 points. Connect your graph, make sure it's curved at the end, and we're done with our quadratic. Let's do one more example in standard form. So over here on B, again, it asks for my axis of symmetry first. So I'm going to use my negative B over 2A formula. And this one, my A value is 2, my B is 1, and my C is negative 5. So x equals negative b, so negative 1 over 2 times 2. Be sure to simplify your denominator first, especially if you're plugging this in your calculator. 2 times 2 is 4, so my x value here is negative 1/4. So remember, axis of symmetry, always write that as an equation, so x equals negative 1/4. That will also always tell me the x value of my vertex. To find the y value then, we're going to plug negative 1/4 into our equation. So I have y equals 2 times negative 1/4 squared plus a negative 1/4 minus 5. You can plug that into your calculator exactly how it looks. Just make sure that negative 1/4 is inside the parentheses with the squared on the outside. So when you plug that into your calculator, please practice doing this. You will need to be able to do it on the test. We get negative 4. Depending on if you have it as a fraction or a decimal, we get negative 4.625. Our x-intercepts then, we're going to plug in 0 for our y value. So 0 equals 2x squared plus x minus 5. If you try to go ahead and factor this, you're going to find out that you actually can't factor this one. So we're going to use the quadratic formula. So we have x equals negative 1 plus or minus the square root of b squared. So 1 squared minus 4 times a times c all over 2a, so all over 4. Always start by simplifying the number underneath your square root. So 1 squared minus 4 times 2 times a negative 5 is going to give us the square root of 41. Okay. So then that's all over 4. Well, the square root of 41, I can't simplify. It's not going to break down to anything for me. So I'm going to go ahead and I'm going to plug that into my calculator so I can get a decimal estimate of where our x-intercepts are going to be. So I'm going to do negative 1 plus the square root of 41. I'll take that answer and I'll divide it by 4. So I know one of my x-intercepts is going to be at 1.350. Then I'm going to use the subtraction sign this time. So negative 1 minus the square root of 41. Divide that answer by 4. And my other x-intercept is at negative 1.85, comma 0. To find my y-intercepts, remember we said we plug in 0 for x, or it's always going to be the constant in standard form. So I know my y-intercept here is 0, negative 5. To graph these, we do have a lot of decimals, a lot of ugly numbers. That's okay. If I want to graph my vertex at negative 1/4, I know negative 1/4 is between 0 and negative 1, but it's going to be closer to 0. Negative 4.625 is going to be between negative 4 and negative 5. So I'm just going to have a point there in the middle of that box. I have my y-intercept at 0, negative 5. So that's going to be really close to that. Something is... Okay, I made a mistake here. Let's figure out where that is. Okay, sorry about that. I realized when I was graphing this that 0, negative 5 would actually be below my vertex and my graph should be opening up, so I knew I made a mistake. I re-looked at my vertex and I realized I plugged negative 1/4 into my calculator wrong. So really we should be at negative 1/4, negative 5.125 for your vertex. So this equation was correct, so maybe when you typed that in earlier, you noticed I got the wrong number. Sorry about that. So I'm going to go ahead and I am going to move my vertex down. Instead of negative 4, it's going to be under negative 5. So then I have my y-intercept over at 0, -5. I have my two x-intercepts at 1.35 and -1.85. Okay. I can use my axis of symmetry to reflect my -5, and now I have my quadratic graph. Please come in if you have any questions. Sorry about that mistake.